When you acquire data from various systems, data can often be messy, whether it be because of mergers and acquisitions and you've acquired various companies in the past and data is coming from different companies, or whether it is because you have various source systems in your environment and you're trying to gather data across all of those systems to build a global system. Data is often messy and there are various issues with the data, which requires you to do entity resolution, sometimes identity resolution at scale, and being able to make sense of all that data across source systems. So here I'm showing three different examples where your data might be messy because it is coming from various systems, right? The first one is identity resolution. Well, if you ask 10 people in a room and ask them to spell Matthew McConaughey, I'm sure everybody will get a different spelling. I don't even know which one is the correct spelling out of those, right? So that is one reason. But then that's not only it. Some system might store first name on only the last initial, or the first initial and only the last name. Some system might have a middle name. So there are all these different combinations. And when the data is coming in, you need to understand how to make sure that you identify the same person across various systems so that you can build a complete persona of that person. There is a similar issue with address resolution. So address is not standardized across various systems. For example, over here you will see 20 West 34th Street floor 20 and 20 34th Street floor 20 and 20 West 34th Street 20th floor. All of these might refer to the same address coming in from various systems, but they have to be matched together to build a complete view of the address again in this scenario. Similar is the situation whether you have product SKUs or whether you have something else where different product names and product description might be assigned to the same product. So, for instance, in this example, you will see that this insurance company has acquired various companies in the past and they have different plans, but they all might mean the same thing, whether it is data breach response coverage or customer breach assistant coverage or incident response expense protection or and so on and so forth. These are all different products, but they might actually mean the same thing or they might have a similar category. So, in order to match all these records across different systems, you need to be able to do effective entity resolution and master data management. Let me show you how we do it. So this is our pipeline for entity resolution. You will see that it starts with entity extraction. So you gotta start with extracting entities from structured and unstructured and sometimes semi-structured data sources, whether the data is coming from various data warehouses, sometimes in CRM system and an ERP system and so on and so forth, or whether it is coming from documents, whether it be scanned documents, for example, claim documents or forms and things like that. You need to extract the entities, attach it to different records, and then being able to resolve those entities. And entity resolution can be done using various AI/ML or statistical based algorithms, including validation against third party dataset, for example, maps data. And I'm going to show you an example in just a minute with a live demo, right? You can assign confidence score based on semantic similarity, pairing, or clustering various algorithms there. And these are some of the ways in which we do entity resolution. We might use AI embedding based matching, where we use a Gen AI model to generate embedding on specific fields and then try to find the semantic similarity between those entities. Or we might use third party data. For example, for address resolution, we might use maps data to master a particular record against the standardized record and then try to do entity address matching or entity matching. We might do named entity recognition. This is building custom machine learning models for more complex fields and being able to identify named entities. Or we might do soundex, and what that means is, do the two phrases sound the same when you say it? So somebody might have done a misspelling, but they sound the same, so they wrote a different spelling, right? Or we might do Levenstein distance or a weighted Levenstein distance, and that is done to identify whether if there is a little bit of a mistyping in the spelling mistake kind of scenarios. And or we might do fuzzy matching, which is a combination of some of these things, right? So these are all the different algorithms that we use for entity resolution. And what happens is, as part of this pipeline, the system will generate a entity resolution, and either it will be highly confident that yes, it has found this matching, or it'll have a low confidence, or it'll say no, I don't have this record. So what happens is, if the entity is resolved correctly, it is used to enrich your golden record. It is used to enrich your master data. So in a master data, your golden records is much more richer with additional fields being supplied there. And you create the connection back into the source system to identify which entity is eventually this record linked to. If there is a low confidence, the system throws this into a human in the loop queue, and a human reviewer basically has to accept or reject the mapping before it goes and it gets attached to the golden records. In certain cases, it might be highly confident that it does not have that golden record, in which case the workflow might be that you go ahead and create a golden record in the master data and then enrich it going forward, right? So these are some of the scenarios. All right, so here I have a demo. You can see that on the top I have some golden records. So I'm simulating master data here, and this you can see here we have name, date of birth, email, phone number, and address. And on the bottom we have the input record which is coming in, right? So we have the same fields here. Assume that the fields are already resolved when you're trying to resolve the data. There is a whole different workflow to resolve the fields as well, but we're talking about resolving data right now, right? So now let's say the incoming record is Kathy McCarthy, and you can see that I'm trying to match it to this top record here, right? But if you see here, Kathy McCarthy is spelled here with a K, right? But in our input record, it is spelled with a C. So although it's the same person, here it says Kathy McCarthy MD, here it says Kathy McCarthy with a different spelling. The date of birth is the same, but it's in a different format. The email is the same, and then the phone number is the same with a different format, address is missing the apartment number, and so on and so forth. So for a human it is kind of obvious that we're talking about the first record, but for a data system it is extremely hard to match it because the strings don't match. Even if you capitalize or things like that, it won't match. So how do you actually match an entity to the golden record and make sure you don't end up creating duplicate records for this particular person? So here I hit search, and when I hit search, we are able to find the record, and it gives me a button to explain it. You can generate an explanation, and here you can see it is able to generate a 100% match, and it is able to do that based on three different algorithms that we've added here. We've added SoundX, we've added weighted Levenstein distance, and we've added embedding distance, which is an AI based model, right? So here you can see the input record is this input Kathy McCarthy with a K, and the matched record that it matched to was Kathy McCarthy with a C and an MD in the end, right? But it is able to match them. It is able to match the name using Levenstein distance and the embedding match. So the AI model says is actually the same person. But then we don't rely on only one field, we match multiple fields. The date of birth is exactly the same based on the embedding distance. The email address is exactly the same using all three algorithms. The phone number is the same using the SoundX and the Levenstein distance. The address is the same using Levenstein and embedding, and so on and so forth. And eventually we're able to match all the fields, and we're able to say 100% match. Now this is all configurable. Which algorithms you want to use, you want to use a combination of them. What is the threshold you want to use? We can add additional algorithms and go from there. Let me show you just another example where we use Google Maps data. We use the master data to map it. So here we are trying to resolve places. So we have various places. These are healthcare institutions, and we are trying to match a new incoming record to the master data, right? So here in the golden records, you will see that the first three records are from the same medical building but different offices. So this is 666 Plainsboro Road, suite 424, suite 1020, and suite 432, right? But these are the same building but different offices of doctors, and we're trying to match this record, integrated pediatrics, and you can see that this is the first record here. But we only give 666 Plainsboro Road. We don't give the suite number, the office number, and we're trying to match it. So when I hit search, it is able to give me all the three records, but it is able to say that it is only 75% confident that it is these two records, but 100% confident that it is the top record here on the top with integrated pediatrics. When I click on explain, you will see that apart from doing SoundX, Levenstein distance, and embedding distance, which we were doing previously, the other thing that it does is it generates standardized maps data using the Maps API. So what we're able to do is we're able to take the input record and the matched record and find out what is the Google Maps data. What is the so and Google Maps is just an example. You can have your own master data, and you can say I want to be able to match this data against my master data and then against my golden record. So you might have two different data sets. So you might have multiple trusted data sources. That's the concept here. So here we trust the golden records, but we also trust the master data coming from Google Maps. So we are able to map that this is this clinic, integrated pediatric Sunita Gulati MD, and this is the address, and this one is this one again, and these two are exactly the same. The distance between them is 0 miles. We can actually calculate the physical distance now that we have 2 points on the map, and then we are able to match the records as well, and we are able to say this is 100% match. So these are some of the ways in which you can resolve entities. You could do master data management using machine learning and AI, using generative AI, and for a data integration project, for a data warehouse modernization project where you are ingesting data from various systems, you're trying to break down silos and build a master data for your customers, for your consumers, let's say for a cross-selling use case or anything like that. It is extremely important that you're able to resolve the entities and identities across different systems, and this is exactly what we do here. I hope this was useful. If you're interested in a live demo, please let us know and please subscribe to the channel.